All right, so well, we're starting off our physics with distance and displacement. All right, now before we get to distance and displacement, what we're going to talk about is a couple science terms, I would say, more than a physics terms, but science terms. And the first one is something called a scalar. All a scalar is a quantity that has magnitude, which is size only. So, for example, of scalars, we use them all the time. You got something like you're talking about 5 apples. You say bike 20 kilometers. You have 6 gigabytes on your iPad or something like that. Those are all scalars, all right, because you're just counting. Now, the other thing is that you can have what's called a vector. That is a quantity that has size, but it also has direction also. So if you're talking about something like going 10 meters to the north, or there's a wind that is 37 kilometers an hour, maybe southwest. Those are examples of vectors because not only do they have size, but you also need to know direction also. Now, where that comes into play for us is when we get into physics here and we're talking about something called distance and displacement. All right, so our distance is a scalar, which again means it's only got size. And we use the symbol here, delta D, which is the total length of the path traveled by an object. All right, so we're going to get down to the difference between these two guys because when we talk about displacement, which is also delta D, there's a little bit of a difference here. I'm going to put a little arrow above it because that means we have direction, which again makes it a vector. That is the change in position of an object, including the object's direction. All right, so that's pretty wordy. But what we're going to do is I'm going to show you the difference between these two, distance and displacement, where distance is more like a speedometer on your car, which just measures how far you travel. Doesn't care whether you go backwards, sideways, forwards, over somebody's lawn, whatever. And displacement is more about going the shortest route from where you start to where you finish. All right, so on that note, let's try out a couple questions here. So a car travels 30 kilometers north and then 40 kilometers west. Find the car's total distance. So again, when you're finding distance, which again is delta D, no arrow, all we're looking for here is the numbers. How far did it travel? Well, in this case, it went 30 kilometers north, and then it went 40 kilometers west, which if you add those up, is just that you drove 70 kilometers. That's it. Again, just like the speedometer on your car. It doesn't care where you drove, it just counts out how much those tires rolled around and how far they went. Now, here's the other one. Here's where you kind of see, hopefully we'll see the difference, is when we get to the next example, all right, where we have a bike moves 30 kilometers north and then 40 kilometers south. Find the bike's displacement. All right, so again, I'm looking for delta D, well, it's displacement. So we got a little arrow on it. And so what we have to do is take into account the direction. And so I'm going to add 30 kilometers north plus I'm going to add 40 kilometers south. Oops, south. Now, here's the difference, is that when you're dealing with direction, and for ours, we're always going to have opposite directions because north and south are opposite, left and right, backwards, forwards, those kind of things. So what I'm going to say is I got to make one direction positive and the other negative. So I always tend to make north positive because when we have a compass rose, it's always on the way up. So might as well make it positive. And south on a compass rose. And if you don't, we'll get to a compass rose. It's always down. Compass rose is those things you see on a map, which I'm just going to draw here in the top corner, where we have never enter stinky washrooms. That's how I remember how to write these in the right order. All right, so I always, because of a compass rose, the way it looks, I always make north and east positive when I'm talking about directions that way, and west and south negative. Okay, so now back to where we were at. So now that I have that going on, when I'm finding displacement, so because I say north is positive, I'm going to make that still a 30. All right, but now when I got this plus 40 kilometers south, because it's south, I'm going to go minus 40. All right, now when I calculate that 30 minus 40, well, I'm down 10. That doesn't mean I'm done yet, because when you're talking about displacement, you got to have magnitude and direction, size and direction. And so the size of my answer is 10. And the units on this thing is kilometers. But because that answer was negative, that means my direction is south. So even in this situation, the car distance-wise traveled 70 kilometers. We say that bike's displacement is 10 kilometers south. In other words, if we just wanted to take a shortcut and didn't want to travel 70 kilometers, how would you get to where you from where you started to where you ended up? And the answer is you just go 10 kilometers south. Because again, this person went 30 this way, 30 north. All right, but then they went, after that, they went 40 south. And so displacement just talks about my arrow here in purple. From the start to the finish, what would you have gone? Well, there's our answer there, 10 kilometers south.
You don't like include the
all right, so what's that, sorry?
You don't include the negative 10, like you just write 10?
No, so what the negative sign is telling you is the direction. So if it was a positive 10, that would have meant my direction was north.
Oh, okay.
All right, so the sign is telling me the direction. In distance, it doesn't matter. We don't have minuses because we're just adding them up constantly. But with displacement, one direction's got to be positive, one's got to be negative. So either way, you got to go with that. Now, how's this? I could have said, if I did this again, I could have said that south is positive and north is negative. So then I would have something like this. I would have negative 30 plus 40, which of course, in this case, negative 30 plus 40 is 10, which would mean, because it's positive, 10 kilometers again to the south. So as long as you keep your signs right, you'll get the right answer in the end. But again, because of the compass rose, I always go with north is positive and south is negative. And again, with east and west, I do the same thing, where east is positive and west is negative, just because that's how it looks on a graph, right, when you're doing math. So that's why I keep it that way. All right, so that's the difference between distance and displacement. One's a vector, one's a scalar, and they're calculated different. They have different meanings. Now, which gets us to this, velocity and speed. All right, so velocity or speed, to start off, is a scalar. And this is just like distance and displacement here. And what the speed is all about is it's the total distance traveled by dividing by the total time taken to travel that distance. All right, so your speed is delta D, which again is distance here, scalar, divided by time. And time's always a scalar because time has no direction. All right, now velocity is a vector. So two different words here. They sound similar, like when you're talking in real life, but they are different. And that's just where we have the total displacement is divided by the time. All right, so again, because a vector or a velocity uses displacement, and displacement's a vector, it means velocity is a vector. Same deal with speed, because distance is a scalar, speed is a scalar. All right, so let's try a couple of those, a little bit different. All right, so a woman's car travels 1,500 meters in 60 seconds. What is the speed of the car? So when we're talking about speed, that's what we're looking for. So I go a little V equals. Now, what you're going to notice with me is that always on the side, before I even start, get into a formula, I write down what I know and what I'm trying to find out. I find that's way easier to use the formulas. It makes it way easier and less chance of you messing up. Now, I always, because I'm terrible with English, hence why I'm a math and physics teacher, I always like to read the questions 2 or 3 times. And so I go back and I go, a woman's car travels 1,500 meters in 60 seconds. All right, so now I know my distance, my delta D. is 1,500 meters. All right. And my time, T, is 60 seconds. All right. So again, I'm going to use my formula here. V is equal to delta D over T. All right. So now I know my variables. That's why I write them down. So I make the right substitution here and I plug in. All right. So my distance on the top here is 1,500 meters. All right. My T is 60 seconds. Now I'm going to divide those two. All right, so I take 1,500 and I divide it by 60 seconds, and let's see here, I end up with, round number. Okay, that doesn't happen very often, 25. Now, when we're looking for the units here, see I have a meters on the top, a seconds on the bottom, which a lot of people don't realize is division. You can convert that to English words, and it just means per. So I have meters per second, just like multiplying is of, actually. So in English, division is per. So I have meters per second. So this person's traveling 25 meters per second. All right. So there's again, where we're dealing with just speed in this case. All right. Now we got another one here. The speed of sound is 345 meters per second. All right, when it's 22 degrees Celsius. If it takes 5 seconds to hear thunder from a flash of lightning, which is roughly what happens, how far away did the lightning occur? All right, so how far? How far? We're talking about a distance. All right, so I got a delta D here. That's what I'm trying to find out. All right, the speed of sound. So there's our speed, which is 345 meters per second, which again is true. All right, and our T here, we're talking about takes 5 seconds. All right, so again, I'm going to use my formula. V equals delta D over T. All right, now I'm going to substitute in, and I'm going to show you something here that we're going to use quite a bit in this course. All right, more of a math thing than anything. First of all, I got to make sure everything's in the same units here. So, and what I mean by that is velocity is 345 meters per second. So that means my time's got to be in seconds and my distance is going to be in meters. So everything's good here. Everything's in the right order or right units. All right, and so I'm going to substitute in here. I got a 345 is my velocity equals, I got a delta T here, or delta D, and then my time on the bottom is 5. All right, now here's a math situation I see a lot of people struggle with. I got a number equaling a fraction. All right, here's the easiest way to solve this, and we're going to use this, like I said, a lot in this class, is I'm just going to create a fraction equaling a fraction. And to do that, I'm going to divide 345 by 1. And the reason I'm doing that is because it doesn't change the number. You take anything and you divide it by 1, you get the same answer. Try it on your calculator. 5 divided by 1 is 5. 480 divided by 1 is 480. And here's why I do that. Is when I have a fraction equaling a fraction, I can easily get rid of all the fractions because then I can cross multiply. So what I'm going to do here is cross multiply where I got 1 times delta D. Well, that's just going to be delta D. And then when I cross multiply, I'm going to have 5 times 345. So I'm going to have 5 times 345. All my fractions are gone. That's the beauty of this. All right, and so then when I multiply those two, I get, let's see here, I get 1,725. And again, because my velocity was in meters per second, well, the distance here is meters. All right, and so this is actually something true that happens with thunder and lightning. I'm not sure if you're familiar with this, is that have you ever seen when the flash of lightning hits? Because the speed of light is so fast, it's basically, it's there instantly, pretty much instantly. And so what you do is when there's a flash of lightning, you start counting, and that'll tell you how far away the lightning strike was, because sound Well, when it's 22 degrees, is about 345 meters per second. So if it's the summertime and there's a lightning strikes, or you see lightning, and then you count to 5 seconds, well, that means the lightning strike was 1,725 meters away. And that's why people do that. All right. Roughly, they say for every 3 seconds, it's a kilometer. Roughly. But we're getting more accurate here. All right, let's see what else we got here. Oh, one more. While running, a person travels 28 kilometers west in 2.5 hours. What is her velocity in meters per second? Whoa, okay. So that means, well, let's get to what we got here. But yeah, what is the velocity in meters per second? All right, so because we're looking for velocity, again, that's our V with the arrow. All right, we don't know that. While running, a person travels 28 kilometers. Good for them. I couldn't do that. All right, west. All right, so that is called a displacement because we have magnitude and direction. All right, so my displacement here is 28 kilometers. And that's west. So we'll throw little brackets in here, west. Now, does anybody know how many, because we have an issue here, is that because I want my velocity in meters per second, I got to have my distance, or sorry, displacement or distance in meters. Anybody know how many meters are in a kilometer? No way.
Isn't it
You guys are gonna be
1,000?
driving soon. It's 1,000. Yeah, thank you. You guys are getting your license soon, man. You got to know this stuff. All right, so I'm going to take that 28 times it by 1,000. So it's going to be 28,000 meters fast. All right. Now, time here, we get 2.5 hours. All right. Okay, so time. Let's see here. We got 22.5 hours. All right, but again, here's the problem. We need our time in seconds. So we're going to have to do a couple things here. First, I got to get it in minutes. All right, so, and then to seconds. Now, there is 60 minutes in an hour, right? So I'm going to go 2.5 times 60. Whoops. 2.5 times 60. And looks like that's 150 minutes. Still no good because I got to get it in seconds here. And so, well, there is 60 seconds in a minute. So I'm going to multiply 150 by 60. And now I get 9,000 seconds. All right. So now we got things in the right order or in the right units. All right. So I'm going to use my formula. V equals delta D over T. All right. That's a V, by the way. All right. So now I'm going to substitute in my information here. So I've got my displacement, 28,000 meters. And that is headed west. Again, got to include direction because we're talking about displacement here. We got 9,000 seconds. Got a couple big numbers here. All right, and so I'm going to divide those two. And then I will get my answer. All right, so when I do a little bit of math here, 28,000 meters west divided by 9,000 seconds, I get 3.11. Because I got everything in the right units here, I got meters per second. And because this is velocity, I got to include direction. And I get 3.11 meters per second west. And there we go. So again, distance and speed are scalars, no direction involved. While we have velocity and displacement, which are vectors. And again, displacement's quite a bit different than distance in that with distance, you're just totaling up all the movement, where in displacement, you're just going from start to finish with direction. How would I get from where I started to where I finished? All right, so there we go.